Hello, my lovely FRM friends, and welcome back to another quants reading. This time, we're going to be looking at multivariate random variables. We have already looked at the univariate ones, single variable. Now we want to see multiple variables. We don't have too many slides here for this reading. The reading is fairly abstract for the non-mathematician, so we're going to try to make it as pleasant as possible. I think what I'm going to try and do here is give you my takeaways, my personal takeaways from the readings, and see how you feel about it. But let's get started, and I'll show you some formulae that I think are important. And here I have already pre-drawn some formulae that I think are important. I don't necessarily think they will be tested mathematically, as in you having to calculate too much. But I think you need to spend a little bit of time appreciating this formula. So number one, I have looked at again at the variance of a variable. Now remember, sigma is the Greek letter that we use for standard deviation, which is our bread and butter metric of risk, of variability. And when we square standard deviation, that is known as variance. Okay? So now the property here of variance, or rather the definition of variance using the expectation operator, is that variance is the expectation of the deviations of the random variable, in this case x, from its mean mu squared. Okay, and if you want to kind of link with prior readings, we talked about the second central moment being the variance, and here you can see that we are taking these deviations and squaring them, and that's a second moment basically, but it is also our metric of variability. Now, I also said in a prior reading that sometimes it's more convenient to use an alternative definition of variance. In fact, they are mathematically identical. It's just a more convenient mathematical expression. And that is to say that variance is the expectation of the random variable squared minus the expected value of x squared. And as I said previously, they may look like the same thing, but they are not. And when you take the difference between these two values, you will obtain the variance of x. Now, the second formula I decided to give you from this reading is the